My main point of critique, though, is that the guidelines are, in my opinion, too restrictive. In particular, this absolute statement at the beginning that computational models and the algorithms underlying AI and machine learning are per se of an abstract mathematical nature, irrespective of whether they can be trained, that's, in my opinion, unjustified. And here's why. It's a 5-step argument. Number one, so first of all, this statement is not backed by any case law. In fact, I'm not aware of any Board of Appeal decision that would have taken such an absolute stance, and there's also none cited in the guidelines themselves. Secondly, in my opinion, already the inherent purpose of machine learning, namely the act of making a computer learn by itself without being explicitly programmed, also this inherent purpose produces a further technical effect because it equips the computer with new functionality. It lets it become a more powerful tool. And so already for that reason alone, in my opinion, an innovation in machine learning should be considered to contribute to the technical character. Number three, as a supporting argument, well, it may be true that machine learning may have mathematical foundations, of course, but the purpose of the exclusion list in Article 52 EPC, also as far as it mentioned mathematical methods, the purpose is to exclude, let's say, theoretical advancements from being patented, from being monopolized. But machine learning is certainly applied science, and many, if not most, of the greatest fundamental patentable inventions are based on applied scientific improvements. My fourth argument, talking about the practicability of AI, I think there's absolutely no denying that AI is one of the most important technological advancements we have today. And the question is it really the right way to exclude this technology per se from the patent system? I think it must not be excluded from a policy standpoint too. And lastly, my fifth point is that AI and machine learning is pretty similar to other domains that make heavy use of mathematical ideas and mathematical concepts. For example, look at telecommunications. In telecom, any math applied to the electronic communications is automatically technical. For example, new encoding methods, new compression algorithms, mathematical error correction methods. All of those are pure math, but they are technical when they are mentioned in the context of telecommunications. So the question is really, should math applied to machine learning to provide a more powerful computer be non-technical? I don't think that that's the case. But my point is that math applied to machine learning, that's already enough to make it technical. I don't think we would need to force applicants to limit themselves to concrete use cases like, I don't know, optimizing the shape of an airplane wing. That's far too specific and far too limiting. Applying math to machine learning, to the field of machine learning, that should be considered technical already.